Bismillahirrahmanirrahim. Assalamu alaikum, dear students. How are you? I hope you'll be fine. Today we are going to do some questions related to chapter number 14, in which we are going to talk about how to find out the distance between any 2 points on a Cartesian coordinate, Cartesian plane. Okay, so as you can see that the coordinate grid shows the 2 points A and B on this Cartesian plane, and we have to find out the distance between these 2 points. So we are supposed to find out, since we can see that it's a horizontal line where the y coordinate remains the same. As you can see, the y coordinate would be 3 all along this line. So we can conclude from here that on the horizontal line the y coordinate remains same. So the distance we are going to find between the 2 points would be the difference of the x coordinates, okay? And we can see that the distance between the 2 points is 1, 2, 3, 4, 5, 6. 6 units. Here, the distance between the 2 points would be 6 units. Similarly, if we talk about C and D, it's a vertical line. So to find out the distance between these 2 points, we'll start from the top and go at the bottom. 1, 2, 3, 4. So it's 4 units. And here, from F to E, it's 1, 2, 3, 4, 5, and 6. So again, it's 6 units. That's it. To find out the distance between any 2 points, you simply have to find out the difference between the two x coordinates if it's a horizontal line, and between the two y coordinates if it's a vertical line. That's all. Now in the next question, we have to learn how to translate the given shapes given the column vector. So for this, all we need to do is, students, we simply have to look for the coordinates given in the column vector. And you already know that when you translate a 2D shape on a coordinate grid, you move it up or down, and right or left, okay? So if we talk about the first coordinate, that is on the top, it reflects the x coordinate, and the coordinate at the bottom reflects the y coordinate. So if we talk about the first vector, it's 1 comma 2, means we have to move, and since it's positive, means the first one is for right or left, because for the x coordinate we either move to the right or to the left, and if it's positive we will move to the right. Similarly, in the second vector, we have 2 positive. So again, we will move 2 squares to the right. But in the third vector, we have -1, means we will move 1 square to the left. Okay, that's what the column vector means. And for the bottom value, we have to see, do we have to move up or down? So it would be 2 to the upside, -1 means to the left, -2 means to the left. Okay, so for the first vector, it means 1 square to the right and 2 squares up. So let's mark one of the points here. For 1 square up, we will go 1 up, and 2 right, here it comes 2 right. That's how we will mark the points. This one would be the first point. Let me mark it with red. And then for the second one, we will do the same thing. That is 1 up, 2 to the right. Here comes the second point, right? And then this one is the second one. So 1 up, 2 to the right. Here comes the third point. And again, 1 up and 2 to the right. Here comes the fourth point. So that's how we will plot the points. After that, we will simply join the 4 points. And this is the translation of the rectangle using column vector 1 is to 2. Right? Similarly, when it's 2 -1, so what do we have to do? We have to go 2 squares to the right and 1 on the left. So let's start from the bottom part here. 2 squares to the right and 1 left. Sorry, 1 down. It's not left, it's down. Okay. So here's the first point. Then 2 to the right, 1 down. Second point, then 2 to the right, 1 down. Here's the fourth one. And 2 to the right, 1 down. Here's the fourth one. Now, what we will do next? We will simply join these 4 points, and here we will get the translation of this rectangle. That's it. Right. Next, we have -1 comma -2 means we have to go 1 square to the left and 2 down. Here it comes, the first one. 1 square to the left, 2 down. Here's the second one. Then 1 square to the left, 2 down. Here's the third one and the fourth one. That's how we translate the figures. Okay. And here's the translation completed. Now, in question number 59, we have to do the reverse of it. Now we are provided with the shapes, translations, and we have to figure out the column vectors. For the first one, we have to go from shape A to shape B. So first we will move to the right here. Let's mark the corresponding points. This one. These are the two corresponding points of A and B. That is when we will keep the shapes together. So this point will correspond each other. That is one on the other. So we have to figure out the distance between the two in terms of right or left, up and down. If we start moving from here, one, we have to see that how many squares do we have to go to the right side since it's on the right side of A. 1, 2, 3, 4, 5, 6. 6 to the right and 1, 2, 2 up. So the column vector would be 6, 2. Now from shape B to shape C, for this one we simply have to figure out only one point to the corresponding point. We don't need to measure it from each of the 5 or 4 points given. Okay. Now for B to A, again we will do the same corresponding point. This time let us take these 2 points. Okay. Again, first we have to go to the right side. How many boxes? 1, 2, 3 boxes, right? And then we have to go down. 1, 2, 3 here, -3. So it would be 3, comma, -3. Now from shape C to shape A. So let's take the corresponding points, these 2 points. This one to this one. Now from C to A, we have to go back in the backward direction, that is to the left side of C. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to the left, it's -9, but we have to go up. So it would be +1. So the column vector would be 6, -1. Don't forget to write the x coordinate above and y coordinate to the left. Okay, otherwise your answer would be wrong. Sorry, it's not 6, 1, it's -9, 1. Wait, it's -9, comma 1. And for the last one, we have to look for shape C to shape D again. We have to go down first. So let's mark 2 corresponding points, this one to this one. And then 1, 2, 3, 4, 5. 5 down. So it's -5. And then, but first we have to figure out either we are going to the left or to the right. So, okay, fine. This one would be the vector of y coordinate. Okay, and for this one, 1, 2, 3. So again, we are going to the left and down. So both the vectors would be negative, but it's -3 and -5. If you will write -5, -3, your answer would be considered wrong because you have to show the reading of x coordinate above and y coordinate below. Okay, so it's actually supposed to be like this. 1, 2, 3. First, 3 to the left, and then 1, 2, 3, 4, 5, 6 to the 2 downwards, right? Now, after translation, let us learn reflecting shapes. So the keywords that you need to learn about reflecting shapes, it's the shapes must be congruent, and we have to use a mirror line. Either it would be x-axis or it would be y-axis. And how are we supposed to do that? So we will be provided with the objects. As you can see on the screens, we are provided with two different objects. So what we have to do, we have to take each vertex of the object one at a time. So you can see how many vertices do we have in the first object. It's 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. So we have to take each vertex one at a time and plot its reflection in the mirror line. As you can see, the mirror line is y is equals to 3 over here. What does it mean? It means the y-axis, the mirror line, the y-axis is the vertical axis, this one. This one would work as the mirror line in this reflection. And we have to use a ruler to join the reflected vertices with straight lines to produce the image. So what are we supposed to do? It's very simple. Since the vertical line, the y-axis is the mirror line, so we will extend it to the left like this. Okay. And what we will do, we will measure the distance of each vertex with the mirror line. This is 1 unit. This is 1 unit. So what we will do, we will also draw 1 unit here and we will mark the 2 points, right? Then for the third one, how much distance? 1, 2 here. So it would be 1, 2 here, right? Now you can join these 2 points like this. For the third one, we have how much distance? 1, 2, 3. So since it's 3 squares distance, we will again have 1, 2, 3 distance. 3 square distance over here. For the fourth one, we have to go up by 1 square. So we will join the points like this. 1 and 2 above. Like this, see? The distance here of this point is again 1, 2, 3. So what we will do, we will have the same distance here. 1, 1, 2, 3, right? As you can see. Now for the fifth point, it's 1 square more. So it comes here. And then we will go up by 1 square and we will join the points. So you can see that the two shapes are exactly congruent of each other, right? This is the object and this is the image. That's how we will draw the image of the given shape of mirror line y is equals to 3. Okay, and you can see that the two shapes, that is O and I, are congruent to each other. In the second part, we have to draw the image of the given shape in the mirror line X. So what are we supposed to do over here? Now we will extend it like this. 1, 2, 3, 4, and we need not to go down. Since the shape is here 1, 2, 3, 4, 5, 6. Okay. So it would be like this. 1 square here and 3 squares above. 1 square here. 1 square above. Then back. Then above. And here it is. Okay. So it's 1, 2, 3, 4, 5, 6. Let's start from the first vertex. It's here. How much distance? This is the mirror line. Okay. So first we will go down 1 square up to the mirror line. And we have to do the same thing here. Let's first mark the points 1, 2, 3, 4, 5, 6. It says -1, -2, -3, -4, -5, -6. So first we will mark the first point up to 1 square distance. This one is the first point. Then the second point is here. 1, 1. The second point is here. We'll join these 2 points. Then how many squares here? From this vertex, it's 1, 2, 3, 4. 4 squares. So we'll go up to 4 squares. 1, 2, 3, 4 squares here. Right. This is the next point. Let us join it. And then we will go 1 square here, as you can see. Then 1 square down. 1 square back to the left. 1 square down. And we will join it. So you can see the two images, two shapes, that is the object and the image, are congruent to each other. Right? That's it. So you see, the two shapes are exactly congruent to each other, and that's how we draw the images. If the mirror line is y-axis, we will go right to left or left to right. If the mirror line is x-axis, then we will go up to down or down to upwards. That's it. Okay, so students, we talked about the reflection with respect to x-axis and y-axis, but here in this question, to be very specific, we are not supposed to do it like this. Why? Because we are already provided with the mirror lines as y is equals to 3 in the first case and x is equals to 3 in the second case. So what are we supposed to do? Y is equals to 3 means this is y is equals to 3. We will draw a line like this. This is a horizontal line, and with respect to this mirror line we have to draw the reflection. So the reflection would be with respect to this line, this much, the same distance over here of 1 square. So we will draw the same distance here, and the 2 points would be like this. See, these are the 2 points here, right, with the same distance of 1 square, 1 square, and then here the 2 squares, and now we will join them. So the reflection of, no, not here, it would be here actually, like this. See? The two shapes have the same distance with each vertex from each vertex from the mirror line. As you can see over here, it's 1 square, 1 square. It's from here 2 squares and 2 squares, right? Same here, 1 square, 1 square, 2 squares and 2 squares. That's it, right? And same thing here, if we talk about the this one, here the mirror line is y is x is equals to 3. So this point is x is equals to 3. We will draw a line here, and then with the same distance 1, 1, 1, 1, 1, 2, 1, 2, 1, 2, 1, 2. So we will first plot the points 1, 2, 3, 4. So it would be like this. Okay. And then we will go back 1 square here, 1 square here, and a straight line. So that's how the image would look like with the with respect of mirror line x is equals to 3. That's it. Okay. Now you can shade it. So this is the correct mirror image of the given objects with respect to these given lines. That's it. Now, after reflection, after translation, after finding the distance, we have to move to the next exercise. These questions are related to 14.5, that is rotating the shapes. As you can see, the question says rotate the shapes 90-degree clockwise about the center of rotation given. We are provided with the center of rotation of 2, 3 here in the first figure and 3, 4 in the second figure, and we have to rotate it 90 degrees clockwise. Okay, so these are some important components that we have to look for. Since the center is 2, 3 here, and we have to rotate this triangle So basically we have to look for this line. This line is 2 squares. When we will rotate this line to 90 degrees, it would be like this. Upon the rotation of 90 degrees, it will become like this. This is the 90-degree rotation, right? And since it's clockwise, so we will move it in this direction, right? And if it would have been 90-degree anti-clockwise, then the rotation would be here. This is 90-degree rotation, but it is anti-clockwise. Since we have to rotate it to 90 degrees, it means the triangle will move like this. Let us draw the line first. Okay. On this line, this point is here, right? This point is here. And then we have a distance of 2 squares. So we'll draw a distance of 2 squares here. And then we will join these 2 points. So this is how the rotation would look like of 90-degree clockwise. Okay, students? If it would have been on the center here, then how do we rotate the shape? Let me show you. This is the triangle, okay? When we will rotate it, it looks like this. 1, 2, 3, and 4. But it's on its origin. And since the center over here is different from the given figure, so we have to rotate it on this center. Okay? And when we talk about this one, the other figure, again, we have to rotate the shape 90-degree clockwise about the center of rotation given as 3, 4. So first we have to find that where is this center? This is 3, 4 here. This is the center. Okay. So if I'll draw a circle, a triangle like this, and I have to rotate it to 90 degrees. How would it look like after a 90-degree rotation? 90-degree rotation means I have to draw a line, okay? Make a 90-degree over here and we have to rotate it in this direction. So it would look like this. Here. It would come here, right? When you will rotate it on 90-degree clockwise, so the bottom of 3 squares would come right here, making a 90-degree angle between these two, like this, right? And then here, this line, for this line, the 90-degree would be here, right? And then we will join the 2 points. This is how we will rotate the shape. And in the next question, we have to use the information to rotate the shapes 180 degrees. And 180 degrees, either clockwise or anti-clockwise, gives us the same impression. So what are we supposed to do? We will turn the tracing paper 180 degrees. And then we will rotate the image. So the center given over here is 4, 5 like this. What we will do, we will draw a line over here. Okay. And then this is the original shape. Upon rotation, it would look like this. 180-degree rotation, it would look like this exactly. So since this is the center of rotation, the image would look like this, right? Because this is the center. That's it. And when we have to draw an image 90 degrees anti-clockwise, then what will happen? With center 6, 3. It's here. The image is looking like this somewhat, right? So when we will rotate it 90 degree anti-clockwise. If we will rotate it 90-degree clockwise, it would look like this. But when we will rotate it 90-degree anti-clockwise, let's say this is the center point. So how would it look like? It would look like this. Like this, right? So we will draw an image. This would become like this. Uh, for each side of the object and the corresponding image, there will be a 90-degree angle. Then we have this side. So it would become like this. Let us draw finishing lines. First of all, it looks like this, then this. Then for this line, it would look like this. This looks like this. Mhm. Wait. That's how the image would look like. Okay. And if we have to rotate it to 180 degrees, then what would it be? This would be the 180-degree image. And if we have to rotate it 90-degree clockwise, then it would be somewhat look like this. Like this. That's how you will see that it's a complete image. So this one is 90-degree clockwise, this one is 180 degrees, and this one is 90 degrees anti-clock. That's it. Now, in the next question, we are provided with the diagram that shows shapes A, B, C, D, E, and F on a coordinate grid. And we have to describe the rotation that transforms shape A to shape B here. This is shape A. This is shape B. This is a rotation in clockwise direction. Okay. And this works as the center. So the center is minus 3, comma 1. Right? With center minus 3, comma 1. It's a 90-degree clockwise rotation. Right? After that, shape B to shape C. This is shape B and this is shape C. So here, so So if we count the number of squares here, this was shape B. This is shape C. So if you rotate this shape, this is 90° clockwise. This is 180 degrees, right? So this is a rotation of 180 degrees. Now we simply have to figure out the center. So what is the center of these two shapes here? It's -3 to 5. Okay. And since it's -3 to 5, so the distance between -3 to 5 is 8 units. And here it's in the middle. So this is the center, that is 1 comma -2. 1 comma -2, 180-degree rotation, right? So to find out the distance between the two, that is what is the center, what are you supposed to do? You take the corresponding points, and with these corresponding points, find out the distance between these 2 points here, right? And here. So in this one, we have a distance of 2 units. So this would be the, if you draw a line over here, this would be the center of rotation. And between these two lines, we have 8 units. So 4 units would be the center. So that's how it becomes the center of rotation. After that, we have shape C to shape D. So this is shape C. And when we will rotate it 90-degree anti-clockwise, it will be D. So the rotation of C to D is 90-degree anti-clockwise, first of all. Okay. And the center of rotation is here. This point is center of rotation, that is 5 comma -3. Okay. After that, we have to figure the rotation of shape D to shape E. Shape D. This is shape D. And when we will rotate it, see, this is 180-degree rotation because this is 90-degree rotation clockwise, and then this is 180-degree rotation. So from D to E, it's a 90-degree rotation. So this is 1, 2, 3, 4, 4 units, right? This would be the center, right? No, this is the center. So this point is actually 4.5 comma -1. And the rotation is 180-degree rotation, right? And the last one is E to F. Right, so this is the center, okay? And the rotation is from E to F is, this is E, when we will rotate it, This is 90-degree anti-clockwise rotation. Sorry, clockwise rotation. And then, no, sorry, anti-clockwise. And this is anti-clockwise 180-degree rotation, right? So that's how F would look like. With center 3, comma 2. This is 180-degree rotation. That's it. Okay. Now, the last one is related to enlarging shapes. So, an enlargement of a shape is a copy of the shape that changes the length but keeps the same proportions. Okay, so if you we look at the first one, and every length on the object is not every length, the length at the bottom is 2 squares, and from bottom to top it's 3 squares, and the scale factor is 2. So it means we have to multiply each length by 2. If we multiply each length by 2, 2 multiplied by 2 becomes 4, and 3 multiplied by 2 becomes 6. So the image for this one would be um, 1, 2, 3, 4. Okay. And here we will go 1, 2, 3, 4, 5, 6. Right. So this is the enlarged shape. Here in the second part, we have scale factor 3. And no, wait. The centers are already given, marked on the diagram. Okay. So here it would be 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. This would be the enlarged shape, right? Now, here we have how many squares? 1, 2, 3, 4. So the scale factor 3 means 3 fours are 12. Hmm. 1, 2, 3, 4, 5, 6. So for this we have to go 4 threes are 12. It would be 12 squares here. Then 2 threes are 6. For 2 squares we have to 2 threes are 6. Right? And 1 into 3 is 3. 2 into 3 is 6. And 1 into 3 is 3. This is 3. This is 3. This is 6. This is 6. This would be the enlarged shape. For the next one, we have scale factor 4. So for 1, it would be 1, 2, 3, 4, right? And then we will go down 1, 2, 3, 4, like this. Then again, 1, 2, 3, 4, like this. And then again, 1, 2, 3, 4, like this. And then 2 fours are 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then 2 squares would be again 1, 2, 3, 4, 5, 6, 7, 8. This would be the enlarged figure of a scale factor 4 for the given one, right? So basically, we will simply multiply the number of squares with the scale factor and draw the lengths accordingly. Okay, the next one is scale factor 2. So 2 twos are 4. This center 1, 2, 1, 2. Okay. And then the perpendicular line is 3 squares. So 3 twos are 6. 1, 2, 3, 4, 5, 6. and then we will join the lines. So this would be the enlarged figure. For the next one, it's a scale factor 3. So we will go down 1, 2, 3. And 2 threes are 6. 1, 2, 3, 4, 5, 6. We'll again go up 1, 2, 3. Okay. And then we have to go 1 square up, means we will go 3 squares up here. So 1, 2, 3 and 1, 2, 3. Right. After that, we are provided with the scale factor 2. So it would be 1, 2, 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. 2 twos are 4. And then 2 squares front. So we'll go up till here. That's how we will join it. That's it, right? So here we have completed questions related to enlargement and rotation and translation and finding the distance between any 2 points. We have completed with this chapter. I hope it helps you out, inshallah. Take care. Allah Hafiz.